In the previous video, I showed you how to make a stack using a vector, compositing a new stack class basically built around a vector. That class works really well. You can make copies of it, you can initialize it, you can push and pop and top and empty and clear. It works great, and that is a perfectly fine class. However, let's say you had some evil boss that didn't want to let you use a vector in implementing your stack. For some reason, you had to build a stack out of, say, for instance, arrays. Well, in that case, you would have to use dynamic memory. You would have to allocate an array at runtime because when you're compiling your code, you don't know how big of a stack is going to be needed. Maybe they may need to make a stack that can hold 10 things. Maybe they need to make a stack that can hold 1,000,000 things. It means you can't know the size of your array at compile time, which means you need to use new and delete to control that array. Now, this is a lot trickier, and in fact, the version I'm going to show you in this video is actually wrong. It's not correct, but it's important for you to understand why it's wrong, and in later videos, we'll show you how to correct it to be the way that you want it to be. So even though I'm telling you that the implementation I'm showing you in this video is wrong, I want you to learn what's wrong with it so that you don't make this mistake in your own code. Okay. So what we're going to be doing is we're going to be making a stack that uses dynamically allocated arrays, where we're going to make a new array of a given size, and then we're going to be responsible for deleting that array when this class is deconstructed. And so the example is linked to, as always, but what I'm going to do is I'm going to show you, before we go on, a quick reminder about defaults. So you can always say equals default for the member functions that C++ provides for you by default. So for instance, C++ is happy to give you a default constructor and a copy constructor and an assignment operator and a deconstructor and a copy constructor even. It's more than happy to give you these default values without you having to say a thing about them. However, it's good practice that if you're relying on C++ providing these functions, to be explicit about it. It's a good idea to say, yes, I know my class needs to be copied, and I'm going to say it's equal to default so that anybody reading my code knows that this is a method that I've given some thought to and it should be provided. All right, so that being said, let's look at the code. So what we have here is a stack, and it has a character array, or really a pointer to a character array, because once again, pointers and arrays are almost the exact same thing. We have a size t, which represents the size of the array, and a size t, which represents the index of the top of the stack. So this lets us keep track of how much of the array we're using and where the top of the stack is. Now, these are three private variables. Remember, the user of the stack should never be messing with these variables directly. They should be calling top, push, empty, full, things like that. Now, one problem with our stack is that we only have one array in our stack. So let's say that when you create a stack, you have to specify what the size of the stack can be. Once again, how big of an array do we need? So you can say, hey, when I make this stack, I'll never push more than 10 things onto it. This is a big limitation to using a stack. We'll show you later more improved versions of stacks that don't have these problems. The other thing to note is this explicit keyword right here. What does the explicit mean? It means that when I'm creating a stack, you have to say stack parentheses and pass in a number here. This looks a whole lot like a conversion constructor, doesn't it? It takes one argument, and I don't want people to be able to say stack equals 10 and for it to call this constructor. I want to be, when you're creating a stack, I want you to have to say stack and put the parentheses there so that you don't accidentally get times when you're like converting unsigned integers into stacks. All right. Now, what are these next three things? These are the rule of three member functions. And note that I'm saying they're all equal to default. I could have just removed these three lines. The code would do exactly the same thing. And the rest of the member functions are identical to the previous example, at least in their declaration. However, once again, there are some problems with our code. First thing is that the stack only makes a single array. It can't make that array bigger or smaller as time goes on. The other bigger problem is the fact that we're using the defaults for the rule of 3, and I'll explain why in a little bit. So how are those member functions implemented? So here we're making our constructor for a stack. Once again, it takes a size t, and we're saying we're going to make an array that's that size out of characters, and our array is equal to that. Now, what do the parentheses here mean? The parentheses here mean I'm initializing this character array with nothing, which means all the characters will start with a default 0 value, which in this case I don't think actually matters all that much. We want the size of our array to be equal to the size that was passed in, so we can remember that. And we want the top of our array to be at position 0. And so this top indicates basically the position where the top value, or this is one past the position of the top value. Now, why is that important? Well, let's actually skip the top one right here. Actually, no, let's not skip it. So here we have the top member function. It returns a character. And what it does is it returns the thing in the array at top minus 1. Once again, the array starts, or the stack starts with top equal to 0. And this top is always pointing 1 past the last element that was pushed in. So we should always subtract 1 from that. Now note, there's a big problem, is that if we have a new array and there's nothing in there, what's 0 minus 1? 0 minus 1 will become an enormous value because top is a size t, it's an unsigned integer. So our top here doesn't even have all of the exception checking that we had before, but we could add that back in if we wanted to. So we're going to just assume that the array has some values in it. All right, well, how do we push a character? Well, what we have to do is we have to take our top and we want to assign the element to where top is pointing. So the first time through, top will be 0. This will put an element in array position 0. Note that we have the plus plus here. This is the postfix increment, meaning that this top will then become 1 larger after this expression is done. So it's saying array is equal to bracket 0 equals element, and then that 0 will become a 1 after this expression because that's what postfix does. All right. What does pop do? Well, pop just makes the top get 1 smaller. So it makes the top become, go to the left 1 position. All right, so that's not too bad. Once again, we don't have our exception checking code because I removed it so that we can save space here. How do you check if the stack is empty? Well, if the top is equal to 0, it means there's no meaningful elements in our array. And then we have another member function called full, which tells us if our stack is full. If the top is equal to the size of the array, we don't have room for any more things in our stack. Now, once again, when we're using a vector, it didn't have a full thing because a vector is allowed to grow in size as needed, but our version of a stack can't do that. Okay, so the member functions that we have right here, these are all implemented fairly well. We could add some new exception checking and things like that, but otherwise these look pretty good. The problem is the rule of 3. So what happens when you make a copy of a stack? Well, the problem is that by default, when you do a copy, it copies each of the 3 data members, the size, the top, and the array. Now, copying the size isn't a big deal. The new stack should probably have the same size. Copying the top unsigned integer, this top size t, that's not a problem. The new stack should probably also have the top in the same position. But the problem is this copying this array. This array here is a pointer because all arrays are really pointers. When you copy an array, you're making really here it's a copy of a pointer. Now the problem here is that once again we're copying the size, we're copying the top, we're copying the pointer here. The problem is what happens when you copy one pointer to another? What happens is you make a new pointer and you get both of those pointers pointing at the same location. Let me show this visually. So once again, when we're copying these 3 elements, we do copy the array. We have a new pointer here, but this pointer has the same value as this pointer. They're pointing at the same chunk of memory, the same array, the same data. So when you push onto this stack this stack's array will also be changed, which should not be the case. When you make one copy of a stack, you should have an entirely independent stack that doesn't have this weird connection to the stack that it was copied with. This is the big problem with this implementation of a stack.